Okay, moving on to section 10.5, Introduction to Functions and Function Notation. First thing we need to start looking at here is notice that we're kind of changing things up just a little bit, so don't get too freaked out. Okay, we all know what ordered pairs are. Ordered pairs are anything that consists of X and Y. Well, notice that ordered pairs can be other things, like here where it says child, mother, city, state, name, batting averages. What does that mean? It means that these things can relate to each other. This can be related to that. X is related to Y. Y is related back. Okay? This is going to become more apparent as we kind of keep going along here. So, whenever you hear me say in class a relation, it is just a set of ordered pairs of real numbers. Real numbers, okay? So, we will use things like X and Y. Okay. So, the domain, D, of a relation is a set of all first coordinates in the relation. Here is our first coordinate. So, first coordinate will be all your X's. The range, or R, of a relation is the set of all second coordinates. Okay, so we have our second there, and that is going to consist of all the Y. Let's scroll down and see what I'm talking about here. Okay. Find the domain and range for each of the following relations. Okay. First things first, let's do domain. Okay. Remember, domain is going to be the X coordinates. Okay. Which we will denote with a uppercase letter D. All we're going to do, since we're looking for the X's, look, we're going to go through here and find all the X coordinates. We do not need to write something twice. Okay, so to find the domain and range for each of the following, the domain for this one would be 5, 6, and -1. Okay, now let's find the range. Okay, range is going to be all the Y coordinates. Okay, denoted with uppercase R, and they are going to be here. We're going to find Y, 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 and Y. Well, notice here we've got two 2's. We do not have to write both 2's. So you're going to have 7, 2, and 3. Looking at this graphically, we can see here, here's our range. And the best way I've ever heard this described is, I'll do this in red. Let's say we have a little guy, and he is walking along the X coordinate here. Now, he's just going to be walking, and then all of a sudden, whenever he gets to a point here, okay, walking across the X coordinate, and he looks up or down, what does he see? Well, he's going to see that all of a sudden, at -1, he hits this, and if he keeps walking, when he hits the 3, and he looks up and down, in this area here, he's going to see this line passing through. So that would be the domain. Okay, well, take your same little guy, put him here on the y-axis, and pretend he's climbing up, and so as he travels up and he's looking left or right, he doesn't see anything until he hits 0. Okay, and then he keeps climbing, and when he gets to 6, he still sees it, but once he goes past the 6, he doesn't see it anymore. Same thing here, whereas on this picture, as you're walking along the x-axis, you look up and down over this little guy. You look up, notice this line is a point, or there's an arrow here. This means this is going to go on for infinity in either direction. So eventually you could imagine if he could just have infinite vision up, he's going to see this. So the domain, as you can see here, would be -infinity because it's going to go off to -infinity to +infinity. That's the domain. Once again, take your little guy, have him start climbing up, and notice that as he looks left and right, he doesn't see anything until he gets to the -2 here. Well, once he starts climbing, Once again, notice this line's never going to stop. So the range will be -2 to infinity. And you can see here in interval notation and how you would write that. Okay, you're going to see this a little bit more in some Hawks lessons and stuff, and we'll go through some examples. Carry on to the next lesson. I just kind of made this one kind of short, and then we'll do one more little quick lesson as a part 2.